Greetings. This is the first homework assignment in Chapter 4, Probability. I want to start out by congratulating you all. First exam results were really fantastic. Out of 22 people, there were 11 A's, 2 100s, and there were 7 B's. So folks were off to a good start. It's always nice to start off with a good grade. It gives you confidence for the remainder of the course. But I will say this, statistically, I've done this course a number of times, 20, 25, if not more. What I'm telling you is that statistically, chapter 4 is the most difficult. This is why when we have exam number 2, it'll just be on chapter 4, section 4.1, 4.2, and 4.3. All right, so I advise you to make sure you're watching these voiceovers, you're doing the homework, posting any questions you have to the discussion board. Chapter 4 is all that and then some. So please do not sleep on it. I'm not trying to scare you. I'm just telling you. Statistically, the grades plummet in Chapter 4. There are only 3 sections, but within each section, 4.2 is a couple things going on, ands and or probabilities. And in Section 4.3, we get into counting. We work with combinations and permutations. So just be advised. All right. That being said, I don't want to scare anybody, but just giving you the facts. Number 1, 2, and 3 express the indicated degree of likelihood as a probability value. Well, we know this. Probabilities range from 0 to 1 inclusive. Probability of 0 means something can happen. Probability of 1 means it's certain to happen. The closer you get to 1, the more likely it is. The closer you get to 0, the less likely it is. Number 1, you have a 50-50 chance of choosing the correct answer. Well, your probability is 0.50. Sure is not 0.9. 50, well, that's way bigger than 1, and I don't know how they're getting 0.25. The only answer even makes any kind of sense. 50-50 chance, your probability is 0.5 or 0.50. Calculating the exact value of pi. Well, pi is an irrational number. Expressed as a decimal, it doesn't end, neither does it terminate. It goes on and on infinitely. All right, supercomputers have tried to calculate pi to millions of places. Guess what? There is no exact value. Never was, never will be. So the probability that you're going to calculate it is 0. Ain't going to happen. Right? It'll definitely, definitely turn dark tonight. Well, that's a sure thing. Probability is 1. All right. I had a person in class answer this as I think 0.5. And I asked the person, well, why did you answer that? Well, what if we're in Alaska? So I opened, this is a night class, mind you. I opened the curtains. I said, look outside. Are we in Alaska? Person said, no. The idea is you don't want to fall for make a silly mistake. But then again, you don't want to be looking for the abstract. What if I'm in Alaska? Well, no, you're not in Alaska. You're sitting at home, and chances are you're in Massachusetts. All right. So please don't be looking for the absurd, weirdest answer. I'm not trying to trick you here. It's going to get dark tonight. Yeah. The sun goes down, and, by 9 o'clock, it's dark. Sure thing. 1. Which of the following cannot be a probability? Well, can't be negative. Probabilities can't be negative. I tell you why is that probabilities are normally found when you have equally likely events. It's the favorable outcomes over the total amount of outcomes. To get a negative number, you'd have to have the total number of outcomes be a negative value of the possible outcomes, favorable outcomes. That can happen. All right, so 0, 1 half, and 1 are fine. Probabilities can't be negative. All right, it can't be bigger than 1. They sure as heck can't be negative. Number 5, what's the probability of an event that's certain to occur? Well, I've just been saying that in the previous example. 1, sure thing. All right. On a multiple choice test, there are 4 possible answers for each question. All right, so already we know the total number of outcomes. There are 4, A, B, C, and D, for instance. What's the probability of answering the question correctly? Well, if you get a multiple choice question, only one of those 4 answers is correct. Number of favorable outcomes is 1. Total number of outcomes is 4. Probability you guessed the right answer is 1/4. Notice, I want to make a point here. He's saying or she's saying guess. All right. Obviously, if you study for a test, you would hope that the probability of you getting it right is better than one chance in four. Why they're saying guess, an uninformed student, person that's never had the subject, they're guessing. A youngster, all right, one chance in four. There are five questions, it'd be one in five. Six questions, probability of getting it right, one in six, and so forth. Number seven, sample space consists of 174 separate events. Well, total number of events, total number of outcomes is 174. What's the probability of each one? Well, each one is one out of 174. I don't know how to get in some of these other answers here. 174, yeah, it's going to be a probability, all right. No way. A die has six sides and it's rolled. What's the probability of rolling a number less than five? Well, total number of outcomes is six. There's six sides to a die. How many numbers are less than number five? Four is, the three is, the two is, the one is. All right, so there are four out of those six, all right, that are less than five. Now, 4/6 raised to lowest terms is 2/3. Number nine, two six-sided die are rolled. What's the probability that some of the two dice will be a four? This is off that sheet, that PDF that I gave you. All right. There are three ways of getting a four: a one on the first die, a one on the first die, a three on the second, a two and a two. It can only happen one way, two, two, and a three on the first die and a one on the second die. So three out of, now if you counted all those combinations on that PDF file, there are 36 different ways of getting totals when you roll two die. All right, so favorable would be three ways of getting a four out of a total of 36, reduced down to lowest terms, 1/12. The class consists of 66 women and 98 men. Well, first of all, they haven't told you the total. Well, how hard is that to figure out? 66 plus 98, that gives you your 164 total number of outcomes. What's the probability of selecting a woman? Well, he tells you there's 66 women. Favorable is 66. Total is the sum of 66 and 98, or 164. You're going to see in many of these problems, they leave a little bit out, a piece out. Well, the piece here they left out is the total. Well, it wasn't all that difficult to add 66 and 98 to get 164. Reduce the lowest terms, 33 over 82. Data set represents income levels of the members of a country club. Find the probability that a randomly selected member earns at least 97,000. Well, favorable over total. I count 20 different yearly salaries here. All right. Out of the 20, how many were favorable? How many were at least 97,000? Well, it's a total of 14. You see them underlined in red. Right? Those are all at least 97 and above. Favorable is 14, total is 20. 1420 is expressed as a decimal, 0.7. In a certain class of students, there are 9 boys and 3 girls, and these, can you pronounce these cities or where they're supposed to be? Anyways, he's asking us here, what's the probability the student will be a boy? Well, first thing, what's the total number of students? If I add the number of boys with the number of girls, I get 37. That's the sum of boys and girls. Now, out of those 37, how many were boys? 9 and 7, and 3 more make 19. 19 out of 37. And your calculator will take this and express it as a decimal, 0.514. Favorable 19, total 37. Of 1,982 people who came to the blood bank to give blood, 340 had high blood pressure. What's the probability to the next person? Now, these aren't favorable. This is frequencies. How many times did it happen in the past? They assume that that same percentage is going to hold true in the future. In the past, 340 favorable, favorable in this case, having high blood pressure out of a total of 1,982. So the chances are, the probability that the next person that walks in has high blood pressure, this fraction expressed as a decimal is 0.172. But he gave you all you needed. There was a total, and there was the number of favorable. Favorable sometimes isn't always a good thing. All right, having high blood pressure obviously is not a good thing. You flip a coin twice. Well, there's two outcomes for the first flip and two outcomes for the second flip. 2 times 2, my sample space is going to be 4. Two times 2. 2 outcomes for the first flip, 2 out for the second. So if the sample space consists of 4 items, the answer can't very well be C and it can't be D. D has only 3 in the sample space. C has 2. All right, and the reason it's letter B and not, I'm sorry, letter A, not letter B. If you look at letter B here, you have a heads, tails twice. So your outcomes would be a sample space would be a heads and a heads, heads and a tails, or it could be a tails and a heads or a tails and a tail. 4 items in the sample space, 4 outcomes. That being said, if you flip a coin 3 times, the first toss, 2 outcomes are possible, heads or tails. Second toss, 2 outcomes, heads or tails. And the third, heads or tails. 2 times 2 times 2 is 8. So there's 8 events in the sample space. All right, so it can't very well be letter A. There's only 7 there, and it can't be letter C. There's only, 6 there. So it's letter D. And the reason it's not letter B, you can look very carefully. Letter B has heads, tails, tails, and heads, tails, tails repeated twice. All right, so I knew it was 8. So I knew it wasn't A, and I knew it wasn't C. The reason it was 8, it was 2 outcomes times 2 times 2, 8. And then I had it down to B and D, but B had the same heads, tails, tails repeated twice. These odds against, all right, odds against is the probability that the event does not happen over the probability that it does happen. Here's that little formula there. And this is one I'm pretty sure I did in the PowerPoint. Probably the odds against answering the multiple choice question. It has 6 possible answers. Well, what's the probability that I don't get it right? Well, there's 5 favorable wrong answers. 5 out of a total of 6. There's only 1 that is favorable. That's the right answer. So 5/6 to complement over 1/6. And when you divide, you multiply by the reciprocal. These 6's cancel out, giving you 5-1. I'm pretty sure I did this in the PowerPoint. Number 17, in a certain town, 25% of the people commute to work by bicycle. Well, 25% is 1/4. If a person is randomly selected, what's the odds against someone commuting by bike? Well, it's the probability that someone does not commute to work by bike over the probability that they do. Well, he says 25%, so my denominator is 1/4. 25%, 1/4. If 25% do commute to work by bike, it makes sense that 75% or 3/4 of the population does not. So the probability of not commuting to work by bike is 3/4. Probably that someone does commute to work by bike is 1/4. And here again, when I divide 3/4 by 1/4, it's like 3/4 times 4/1. The fours cancel out and leaving you 3-1. That's the way we express odds, 3-1. Okay, hope that is helpful.